Hello, math nerds. Students been struggling a lot lately with trigonometry, and I want to make sure that that's not going to be a problem going forward. So I thought maybe put together a video where I just cover as many of the basic concepts as possible, just trying to clear up any confusion about what exactly is going on. Because I don't know exactly where the struggles are coming from, I'm going to be forced to review a ton of things. Some of them could be considered extremely basic for some, but others might not think so. So we're just going to take it step by step and show every possible little thing that I could think of that may or may not be causing an issue. Let's begin with the very most fundamental thing that I could think of, and that is our terminology of sides of angles. Angles, classically, and I'm not quite sure why, were decided that they open counterclockwise and that they always begin at the positive x-axis. We would call that the initial side. Now, when an angle is in standard position, the initial side is always the positive x-axis, always. The terminal side is the side of the angle that we can see when we're doing trigonometry. For example, I could draw it over here in quadrant 2, and we would call this the terminal side. Terminal means ending. We're literally saying that this angle started here and ended here. But like I said before, angles are supposed to open counterclockwise. So as long as they do open counterclockwise, we could say that this is a positive angle. Now, it doesn't have to open counterclockwise. It could open clockwise. And if it opened clockwise, it would begin at the positive x-axis because that's where all angles begin, and it would end there. And this would be considered a negative angle. There. And we typically use the Greek letter theta to represent our angles. So just get used to seeing that, T-H-E-T-A, theta. And while we have this picture, we might as well review the concept of what it means for two angles to be coterminal. This terminology means two angles that both begin here, both end in the same spot, so for example, here, but have completely different measures. For now, let's talk about degrees. If I draw an angle in quadrant, 3. Let's just draw one in quadrant 3. Remember, all angles begin at the positive x-axis. I'm going to throw this one in quadrant 3. Picture not drawn to scale because it never is. And I say, okay, if this is 0 degrees, this is 90 degrees, straight line, 180 degrees, 270 degrees. Let's just say that this is, 30 degrees because that's one of our special angles, past 180 degrees. So let's just say the way this sits, this angle is a 210 degree angle. There are an infinite number of positive angles that land here, an infinite number of negative angles that land here, and we need to be comfortable with finding those angles. So here is the original positive angle. Original positive angle, 210 degrees. If I said, give me another positive angle that is coterminal to 210 degrees, it would be the same as starting here, going here, and then turning another full circle, whee, like that. What does that look like, though? That looks like start here, go to our terminal side, but don't stop there. Go another full circle because we're crazy. Why not? And do that. Yes, it began at 0. But notice from here to here was the same as the green angle. I went a total of 210 degrees. And then, because we're nuts, we decided to go another full circle, which gives us this positive angle is the original 210 degrees and another 360 degrees, which is 570 degrees. So the positive angle, 570 degrees, is coterminal to the positive angle, 210 degrees. Of course, I didn't have to have positive only. I could have said, well, give me a coterminal angle, meaning begin here, end here, that's negative. Then that is the shorter trip. Let's use red, it'll show up better. Beginning here and then going clockwise to there. This is really short. It's really not that far of a distance, but mathematically, the easiest way to calculate it is to pretend you took the red trip of 210 degrees and then said, you know what, I'm going to turn a full circle. Not the purple circle. No, I'm going to go, that strangely rhymed, I'm going to go the other direction to complete the red circle. Mathematically, that negative angle would have been saying, I could have gone the 210 degrees, but then turn a negative 360 degrees. The net result is this tiny red line. I'm aware this tiny red line did not start at positive 210 degrees. I know that, but its value can be computed by saying, go the green trip, then turn a whole negative circle, and that's going to give me a negative, I don't know, I can't do basic maths. What is it, 150 degrees. There you go. So if it began here and then went clockwise 150 degrees, you'd land right there. So 570 degrees is coterminal 210 degrees, which is also coterminal to negative 150 degrees. I could keep subtracting 360. I could keep adding 360, and I would keep landing here every single time. All right. So that is the first quote-unquote basic concept. The next, let's just say concept, that way I don't have to keep saying basic because I don't want anybody to be offended by this, is we all need to be clear with the fact that degrees are a man-made thing. There is no such thing as degrees. So to say that there are 360 degrees in a circle is, well, it's baloney. Okay, it is. It's just baloney. It's not a truth of the circle. It's a convenience. We choose 360 degrees to say there's 360 degrees in a circle simply because we can divide it by a lot of stuff. It's a convenient number. But a truth of a circle is that every circle has exactly 2 pi radians within it. A radian being a type of angle that is the exact same measure as the length of the arc it creates. I know that's a weird thing to say, but it literally means take the radius of a circle and whatever that radius is, create a curved line with the exact same length, close up the angle, and that angle would be called a radian. There are exactly 2 pi radians in every circle. So a little bit more than 6 1/4. It's actually a little bit more than 6.28, but we say there are 2 pi radians in every circle because it's a truth of the circle. Made up? Truth. Okay, if there are 360 degrees in every 2 pi radians, or if there are 2 pi radians for every 360 degrees, whichever one you're more comfortable with saying, we all need to be comfortable with the fact that I can divide both these numbers by 2 and say that there are 180 degrees for every pi radians, or again, you could say there's pi radians for every 180 degrees, whichever one you're more comfortable with. But radians are the actual true unit that we're going to be measuring things in. So if this is 0, but it's also 2 pi, it's also 4 pi because these are coterminal for turning whole circles. Halfway through the 2 pi gets me to right here at pi radians.